what was traditionally known as the BIOS. Now it's usually EFI, but we're talking about, do it? It stopped working. Well, that's going to be annoying. This little guy. This is the one on one of the Intel boards. It's a piece of flash. It's not very big. This one's 8 meg, I think. Although the old days, when you were trying to update these, you wound up with something like this, right? And then eventually it got a little bit better, and you wound up with this, but it's still kind of crappy, because what you wound up doing is that, right? And nobody likes doing this. You wind up spending a day building a floppy disk or faking a floppy disk with a CD, right? So I don't like that very much. You don't like that very much. It's kind of bad. And on your firmware, when you look at it, if you look at your vendor and hit the README, you'll find something like this with, there's stuff on it. That's bad. You can literally have a root exploit that the person can exploit and stay on the machine after you do a OS reinstall. Maybe. So you might wonder what we can do about it, and the answer used to be not very much. But then somebody made this little machine. You probably didn't expect me to say how great Microsoft is or how great the Surface is, but it has a feature that is firmware updates organized by the operating system without having to have any special tooling. And, that's a pretty good feature. But we can't use it, right? So they've just got one more feature to sell Windows with. But then they did the right thing, which is really weird, and they wrote EFI's specification in a standards body of how it works. And then they started writing requirements in Windows for how it works. And the structure of the PC market is that they produce a lot of requirements that look like this and have very, very, very specific details in order to put the logo on a laptop. And the logo comes with millions of dollars of marketing money. So if the laptop vendor puts the logo on it, then their laptop is profitable. And if they don't, it isn't. So they have to do the requirements. And there's audit processes and everything. But that's a tool I can use. And then somebody else made this machine, which is an Intel Galileo. And it gave me something that we can use to inspect what's going on, because it has a lot of debug parts. So that was my desk for a while. I looked for a better photo, but oh well. And I learned a lot of things that they say about how it works aren't really true. And then wrote a lot of code. And then somebody sent me an actual machine that supported this that I could test on, and so I wrote a demo. And that's my cue to play the demo. And this is hooked up, this is from my phone, obviously. And this is the demo I gave to the Red Hat desktop team 2 years ago now. And it's just set up the machine to reboot into a firmware updater. And then this is the screen telling you it has no signal. And then that goes away. And for a while, nothing happens. And it is a long while. So I'm going to fast forward and then rewind to where something happens. So that's a minute later. And somewhere in this 15-second window, thanks, GStreamer. And it says this. And it sits like that for a long, long time. And then eventually it says that. And then it reboots again. And so that's not a great UI, right? Nobody wants to see that. You're just looking at it going, what the hell is going on? But this was the first box that anybody could get me that could do it at all. And so about 4 minutes in, it reboots into Linux, which you can see there. So thank you to Harry at Intel and Jeff at Inside BIOS for actually sending me that machine and getting it working and another one like it. And then Richard Hughes started doing some things that we're going to come back to on the other side of Linux, on the UI end. And then I wrote some code to make something better than what you just saw, and then somebody else sent me another machine to test it on, and a while later, it looked more like that while you're doing the update, which is a bit better. So thank you to Mario and Jared for sending me a laptop that had the support that I could actually make that work on. So you might wonder how it works, and it's actually really simple. The system firmware builds a table in memory that has a list of every part that has a firmware on it that it knows how to upgrade. It's a GUID and a version number that's the lowest number you can upgrade to, which means you can go backwards if it supports it. And then there's a function call called update capsule where we load it into RAM and we call a function. And then we reboot the system, and when you reboot the system, it applies the firmware update. And you have to do that because during booting, it locks off the part so you can't do any writes to it. So the theory is you don't actually want anything running while the OS is running that could change it, because that's exploit city, right? And then the Linux parts, it's actually fairly simple as well. I wrote a kernel driver that just sticks all the data in sysfs, and I wrote a program that copies the firmware file onto the EFI system partition, sets a boot variable to say, hey, next time you boot, run this program, and sets a variable that's in VRAM with some state in it. That's just, hey, by the way, here's what you should look for. And then the stuff Husey was writing. He wrote a whole lot of code. He wrote a daemon that is activated when something looks for it, because it's dbus. And he wrote software into GNOME Software Update so that if your system vendor provides a firmware update, it'll show up in the normal software update stream. So you can just click and apply, and it does all this, and it's beautiful. And he also wrote the Linux vendor firmware service, which is a service we're doing for the hardware vendors, so they can upload their firmware to us in actually the Windows capsule file, cab file that they would update to Microsoft. It's the exact same file. And we distribute it to all the Linux vendors, so everybody can use this. And we suck it down, and just that's how you get the firmware from the vendors, so you don't have to go hunting for it on the internet, right? And he's done a fantastic job, so if you see him, although I don't think he's here, thank him. That's actually the whole of the talk bit, but who wants to see me do it? Thanks, Laura. Now, let's see. Right now, the only thing on my machine, you can see it's set to just boot Fedora. Yeah, but what did I do? What did I do? All right. I have tab completion for it now. As you can see, I've got a lot of options to choose from because, well, I've done this a lot of times. And now it's set up so there's a second boot item. It's not normally in the list of things to boot, but it is the thing that will boot the next time I boot it up, right? It takes a little while. Hopefully it'll sync video, otherwise I'm going to hold the laptop up waving it around at you. Okay, well, waving it around it seems to be. On this one, it takes about 4 minutes, and Dell has packaged all the firmware for every part in one bundle. So right now, it's updating the system BIOS, so it's the main EFI image. In a second, it'll do the embedded controller that drives the keyboard and suspend and all that stuff. Then it'll do the Alpine Ridge, which is the Thunderbolt part. I don't remember if there's anything else there might be. It's just going to keep going. So now it's the USB controller. So I guess we can do Q&A for however much time.
Maybe tell them that you need a firmware upgrade from VGA support.
I think that's actually the dongle, but maybe not. Because I thought I had seen it do it with the DisplayPort output, but we don't have DisplayPort here.
Exit file, so you cannot like select which pieces you want to upgrade. You always have to pass in the whole binary.
So on this one, it's all one bundle, and you can't choose anything. In theory, you can have anything in the list. You can have a whole list of it's GUIDs, right? So you've got a scatter gather list of physical pages and a GUID, and you say update this GUID with this scatter gather list, and you do as many as you want before, and then reboot. And that's a little scary because you don't know what order to apply in, or if it's going to reorder them, or if it knows how, or if there's a specific order you should use. So they'll bundle it all as one. But in the future, one of the things we don't support yet is PCI option ROMs, because none of the vendors have shipped the firmware support for the PCI card to say it has an option ROM you can do, right? So sometime we're going to support that, and that'll have to be two separate ones. Also, one of the things that Richard Hughes wrote is from GNOME software, you can also do USB devices, which is entirely separate infrastructure, but from the interface, it looks exactly the same. And so those would all be separate. We really actually spent a lot of time making it so the Windows cabs would work. So you can take the Windows binary, and so we don't want the hardware vendors to have to come and make a different firmware bundle for us. We want them to use the same ones Windows is using for the least friction for them, to encourage them to do it. And we've actually been getting a little bit of support from did it finish? It finished. I would have thought it would reboot, but it powered off. There it goes.
And what if it fails?
If it fails, I have 2 fancy screwdrivers, a pile of the pry tools, and a firmware programmer in my laptop bag, and a backup from Friday. And that's the enter your password to decrypt the disk screen. So don't watch me do that. Yeah, actually, that's the one thing right. He's asked, did the firmware updater use shim, so is it secure? It's mostly secure. It is secure in that regard. It runs through, it's signed by the Red Hat key, and so shim will load it, and like Secure Boot is on my laptop right now. It is not running something at all that's untrusted. And in theory, the firmware blob has to be checked for security as well, for that it's valid. In the US, there's a publication that's called NIST, the National Institute of Standards and Technology, Special Publication 800-147A, which is a really catchy name, I know, that says that any firmware update has to be cryptographically verified with at least SHA-256 sums and RSA-2048 signatures before it'll apply. And it also says that some really kind of dumb things, like the keyring isn't something that's allowed to be exposed to the operating system. So we can't verify that it actually does it. So at some point, we're going to have it so that we're checking the signature that's on the cab file as well, and we're going to be checking that. Well, we already checked that when you download it, but we don't check it after rebooting before applying the update yet. The reason for that is I already have one OpenSSL fork I have to maintain, and I'd like that to be 0, not 2. So we're waiting for The UEFI 2.6 has a feature where it gives us an RSA signature verification function, but it hasn't rolled out to a lot of machines yet. So once that exists in the wild, then we're going to be able to do that pretty securely.
Do the vendors authenticate themselves somehow if they upload the firmware to the registry?
So you're asking if when they upload to fwupd.org, do they have to authenticate? Right now, we're creating accounts for it on a one-on-one basis, so it's people we've talked to that can upload, and they have to sign in and upload it. And from a practical perspective, the thing they're uploading is the Windows cab file that's signed by WinQual. So they've done two-factor auth and smart cards, HSMs, to sign it, to upload it, and then they download it again. With a signature on it from the Windows CA, who are surprisingly fairly good, trustworthy people who are very straightforward in how you deal with them. We've had a lot of success working with them, actually, because of Secure Boot, where we went through a lot of politics and eventually got a pretty good working relationship with them. Yeah.
When does this hit distribution, Fedora and RHEL?
It's in Fedora 25.
And RHEL?
Not up to me. Oh, he wants to know when it hits distributions. I can't control what goes in RHEL when. I wanted it in 7.3, but it's not. But it's in Fedora 25. Yeah?
I don't want you to get in trouble, but which vendors are working more closely with you than others? For example, on the Firmware update website, have all vendors uploaded?
2 or 3 are talking about it, and so I can't really talk about them, but there are some that are still talking about it. Dell has really gone out of their way to support this. They've spent a lot of engineering time on it. They send us patches when something doesn't work. They've really done a good job. Intel has done a fairly good job. Inside, who makes a lot of system firmwares, gave us test equipment really early on, or rather we found an Intel desktop board that they'd send us a firmware for. So we flashed the first firmware on and then do firmware updates from there. That's really the ones that have really gone out of their way to help. All right, well, I went through those slides faster than I expected, but.
And what about some open source firmware?
He wants to know what about open source firmware? We could support it if they support it. If you're loading, well, so one of the things I built as a test rig very early on was I wrote a driver for EDK2 OVMF, which is the UEFI reference implementation. And I wrote a driver that made it so you could set a EFI variable with a particular GUID and stick in it the header that goes into the table that's the output. And then wrote a driver so when you do the firmware update, it rewrites the variable. So I can test the API out without actually testing any firmware update and make sure that the API actually works. So we have that in a branch somewhere on GitHub. And the upstream EDK2, which is BSD licensed, has support for all of the front-end API, but not and some reference implementation of here's how you flash an SPI flash part, but it doesn't have any of the how you control this one machine glue, right? So you don't know. Like when you ship a machine, you basically build that firmware and then add in a binary blob from Intel or from whoever that says, here's how you support this chipset. And mostly it's like timing data and that sort of thing. So if they have, like if you loaded Core Boot and then loaded EDK2 from it, and they had and they wrote some backend for that API, then it would work. Yeah.
Is it possible to use the servers on other Linux distributions like Debian-based?
So his question is it possible to use our servers on any Linux distribution? Yeah, we don't want in any way to be a Red Hat only thing because it's better for everybody if everybody gets security updates everywhere. And that's a big concern for us. So we initially wrote it just because we needed to have something at all, and we're working with other distros to try to make sure they don't have concerns like, do I get all their user data while they do it or do I know how many Ubuntu machines are updating and they don't? That sort of thing. We're working through that because we really do want this to be something that's applicable absolutely everywhere. Yeah.
You have your choice to fix
Yeah.
failing flash. Is there any chance that there will be like two firmware, so if one fails, it will speak to some backup and you can repair that? Are working on that or?
So the question is, I have my tools for if the flash fails, what can I do? It's take the laptop apart and find the little test clip and all that. And are there any is anybody doing last known good where they've got two firmwares and it'll flash it to the other one that's not in use and then try to boot that? The answer is usually on most of the hardware we've seen so far is all laptops, and that's actually pretty price prohibitive because if your margins per laptop are in cents, the difference between an 8 meg flash part and a 16 meg flash part is about 3 times the price. So you're going from something like 70 cents to something like $4. And so nobody's ever going to do it. On servers, though, there's a pretty good chance that you'll have a system where the actual flashing is done by the I've forgotten the acronym, but the service processor. And so what'll happen is either we use this API or another independent, and we'll upload the flash to the new image to the service processor, and then it will apply the update. And when you reboot, it'll have a watchdog timer that if the system firmware hasn't talked to it soon enough, then what it'll do is just flash the old one in, right? And then reboot it again. All right, well, thank you, and I'm hoping we can bring this to all your systems.
Good. Works.
Yeah.